Okay, fam, welcome back to the channel. Today we're going to be doing something a little bit different. We will be still having a energy drink review. I have this Mountain Dew Kickstart pineapple orange mango. Just because we're trying something different, I figured I'd go with one that I don't think is very popular, so we'll see how that goes. This one has 10% of some kind of juice. I don't know if it's the mango, the pineapple, or the orange. And it also has coconut water inside. So, to tell you the truth, I do not expect to enjoy this beverage. Although pineapple and orange sounds pretty good, I just am not a fan of the coconut water, so I'm not super excited about that. So, if you want to see the can, I'll bring it closer and do a bit of a rotation here. There's no cool description on Mountain Dew cans. So yeah, the other thing that we will be doing today is something that I thought would be kind of fun and different. Let me get it pulled up here and then switch to the scene. My sister found this advent calendar of programming challenges, and we thought that we would do them together. We did the first couple days, and then she kind of got bored, and I got lazy, so I figured that it might be nice to work through a couple of them today. So every day, basically for the last month, they've posted a couple programming challenges to do, and like I said, I did the first 2 days worth, so that's 4 challenges. And there's kind of a narrative through all the challenges that's pretty cute to go through, but I don't want to sort of retread stuff that I've done and go over those things. It'll make this video extra long, so we're going to start just with day 3. So with the toboggan login problem solved, that was the second day challenge. You set off to the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering, and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map, which is your puzzle input, of the open squares, dots, and then trees, which are the hash marks that you can see. For example, and then they give you a sample map. These aren't the only trees, though, due to something you read about once involving arboreal genetics and biome stability, the same pattern of trees repeats to the right many times. So here we've got this same pattern here, and it's kind of a brighter white, sort of with the halo effect around it, and then the same pattern repeated on several times to the right. You start on the open square in the top left corner, and you need to reach the bottom row, so this row, of your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model which prefers rational numbers. So you start by counting all the trees that you would encounter if you chose a slope of 3 right, down 1. So if I went down 1 and 1, 2, 3 to the right, I would hit an open tree, I believe, or an open space. From your starting position at the top left, check that the position is right 3 and down 1. Then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you'd check in the above example are marked with O, where there's an open square, and X, where there's a tree. So here they've got the open square at the start, then an O because it's an open space, an X because it's a tree, an O because it's an open space, and X because it's a tree, all the way down. In this example, traversing the map using the slope would cause you to encounter 7 trees. Starting at the top left corner of your map, following the slope of right 3, down 1, how many trees would you encounter? And then to begin, get your puzzle input. This opens a new tab. As you can see, the actual puzzle input is a lot more complex. There's a lot more data here than in their sample, but that's just to make it the sample easier to read. Now, I don't know, my sister told me that they randomized the sample input for everyone, so it's been a few days since I started this, so I'm going to recopy this out. What I like to do is, I think you can probably download this as a text file somehow, but what I like to do is just open up a text editor, so I'll go with Sublime Text. And I'll redo this, copy and paste. Cool. Now I'll file, save as map.txt, desktop, add code, date 3. Save and replace. Cool, hopefully that worked. I don't really need the input now. The input is actually, at least based on the first 2 days that I did this, the input should stay the same. So let's, now that we know the issue, I'm going to take a sip of this drink. Oh, you know what? This is actually a lot better than I expected. The coconut water isn't super overpowering, and the pineapple and mango really comes through. So that's cool. So this is so here's my map.txt that I just saved, and here's the thing that I wrote out a few days ago when I started this project, but I didn't get very far. This code is stuff that I've used every day so far, basically, and it just defines where I'm going to store the data from the input. I'm using an array list of strings. I might change that to something else, but I'm not sure. And then this, I've got this try catch block, which means basically I'm going to try to do all this stuff, and if there's an error, it's going to catch the error and do this instead, which is, it's just going to print out what the error is, basically. But what I want to happen is to define a file object that is at this location, and I need to replace this with map.txt. That's not how you spell map. Then I've got a scanner, which is a Java object that can read inputs from a file, and I've got my file in there. Then, while the scanner has more to read, a new line to read, it's going to add the next line to my array list. And then when it's all done with lines, when it's got the last line, it's going to close out the scanner object. I'm just going to print, I'll get the first line, and we will compare that to my input file, map.txt. So run, yep, save that, run it. So there's my first line, and let me open up Sublime again. Make sure that's the same. Yeah, it looks about the same. So I'm going to assume that that worked. Alright, so from here, I'm just going to declare an integer variable. We'll call it right, and it'll be set to 3. So that's just the way that the distance that we go to the right every time we go down a line. So now, here we want to get the so all of the lines in our input were the same width, that looping thing. Since it's a loop, we can get the width of the number of characters in the first line, and that'll be the number of characters in every single line in the input. So if I go for lines dot get 0, and then dot, that's a string, so I should be able to say length. And then I want a variable, so I want an integer called, I'll just call it width, because that's the word I used before. So that is equal to the length of the first line. Next, I am going to just go ahead and make a for loop. Or no, I will do I'll do a while loop. So while lines dot size is greater than 0. So while the input has lines, do this, and this is what I'm going to do. I'm going to lines dot remove. Yeah, I'll just do remove the first index. So I'm going to get the first line, and if I remember correctly, This should also return the current line that we're on. Cool. So I need another integer. I'm just going to call this current position, but this only represents the horizontal position, and it'll be set to 0 initially. So what I want to do, let me try to explain what I want to do. On each iteration, it's going to remove the top line, because that's the line that we would be on vertically as we slope down the hill. Then I want to check the position within that row of where we would be horizontally using the current position variable. First thing I need to do is current line dot char line dot char at, and then I should say current position. I'm going to make this an if statement. So if the character at the current position is equal to a hashtag symbol, then this is what I want to happen. I need another integer, so I'm going to go ahead and declare this one. I'll just declare it right here. This will just be num trees, and that is also going to be initialized to 0. So if we hit a tree, then num trees, you add 1 to that number. If not, then you don't add 1 to num trees, so we don't need to write anything. From here, we need to adjust the current position. So current position for the next loop, right? So current position plus equals. So you add on the right. I'm actually going to rename this variable to right adjust. So right adjust. So that'll shift it over by 3. And then if current position is greater than the width of the line, then we need to adjust the current position so that it's within the row on the next iteration. So we are going to do current position equals current position mod, and I believe in Java it's still just a %, the width. And then at the end of all this, we should have no more lines in our thing, so we should have hit the bottom line. And then we're just going to use system.out.println. I like doing print line, not that it matters that much. And I'm just going to say num trees, because that number is getting added to for every tree we hit. Cool. Now, there might be a bug in this, so I'm going to go ahead and run it, see what happens. Index out of range. Where are we? Oops. So that means that at one of these checks, my index is over the width line. Oh, tree finder line 36. So this line, the only time I look at an index is for looking at the char at. So that means that my current position modification did not work properly here after I check it. So I'm going to go ahead and let's do some debugging. I'm going to put a breakpoint. I'm actually going to put a breakpoint on line 42 because then it'll only stop when the current position is above the width. I'm going to go ahead and debug. Yeah, so in Eclipse, there are different perspectives, which is just different window layouts, basically. So here's our code. Here's some debug information. Here's information on the variables that we have. And here's the same console below. So here we are, we're stopped. The current position is greater than the width. So here we've got the current position is 33. the width is 1, there's 31. And let's see if I have my lines right here. So if I go to the very first one, I want to know how many that actually is. Because sometimes with the width, like when you get the size of something, it returns a different value than it actually is. So, because the first index is index 0, and so when you count it, it still counts that as 1. So when you I'm just going to try to redefine width as the size minus 1. And instead of debugging, I'll just save and rerun. I'll just terminate. I think that's left over from the debug. Now I'm going to rerun. So we got 79. That's a number. We didn't get the overflow. So I'm going to copy that. Come back to Chrome. And paste it into here, and we're just going to see if I got the right answer. That is not the right answer. Cool. So clearly that's not right. Now if I'm going to debug this again. Actually, I'm going to re-edit this. I'm going to stop the debug. Restart the debug. So width is 31, that's correct. Current position is 33. I'm going to restart at the while. So at this point we have gone, we want to look at index 33, so that would be the 34th thing. So 34 minus 31 is 3, so this number should be 3. We should want to look at the third index of the next row. So when I press this, we are off by 1. So if I say plus, if I edit this formula to take the mod and then add 1 afterwards, then hopefully it should work correctly from this point on. Still got 79. If I adjust this so that I just change current position to be starting at base 1, and then when I check the chart, I just minus 1 every time, then how does that fix it? 203, that is a different number. Cool. So that was the number. When you get into modulus, it's always a little bit confusing. And if you don't know what modulus is, it's basically division. But then instead of doing a decimal, you just take the remainder. It's taking the remainder. Just the value that is the remainder. You sort of ditch the stuff that can be evenly divided. All right, so now I'm going to continue on to part 2. So time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop. After all, determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. And then it gives you 5 different slopes to check, and you've already checked the first one. So in the above example, these slopes would find 2, 7, and this is back up here in this example, 2, 7, 3, 4, and 2 trees. Respectively multiplied together, this produced the answer 336. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Something that I've been doing in Eclipse, and I'm going to go back to the original perspective on the other days, is I've made 2 different packages for each part. just because I can basically just copy the original code over from the first part and then edit it so that it can just be for the new one. So I'm going to do that again here. So new package, I'm going to call this part 2, and then I'm going to copy this file, and I'm just going to paste it. Open it up, package part 2. So this is the same thing. So now I'm just going to adjust the right adjust thing. So now it's going to be an array of integers. I need to go back to this. It needs to be 1, 3, 5, 7, and then write 1 down 2. So that one's going to be a little trickier. But for now, I'll start with the 1, 3, 5, 7. 1, 3, 5, 7. I'm going to try to do a for each loop, so the syntax for this is a little funky, but I want an int called right. I'm just going to change this to right adjustments, and I want an int called right adjust. So for each integer in right adjustments, I want to do this. Actually, I can Command X. So for each of those things, I am going, for each right adjust, I'm going to do the thing I did before. But this is just the sum of the number of trees, so I actually want these in here as well. The width will be the same for all of the checks. What's the issue here? That's a syntax error. Expected, oh. It wants these kind of brackets, I guess. Dope. Taking another sip. So instead of doing this while loop, I'm just going to I'm going to create another integer array. I'm going to add 1 to this one. I'm going to say down adjustments. And this is going to be 1, 1, 1, 1, and 2. I'm going to change this to current right, and I'm going to make another integer called current down, and it will also be set to 1 because we start in the first position, top left position. Numtrees equals 0, and I also want an integer called trees product. And I'll just set that equal to 1, and I'll explain that later. Alright, now I'm going to change this again to, instead of doing a for each loop, I'm going to create another integer called int I, wait, I can do this in the for loop. Int I equals 0, that's a 1, not an I, and that's an L, not a semicolon. And then I is less than right adjustments dot length, and then I plus plus, that's the same thing as plus equals 1. So now so for each one of these right adjustments, I'm going to create 2 variables that'll determine the position, and then I've got numtrees reset to 0, and then for each line, this needs to change. I'll say while current down is less than or equal to lines dot size, and this is the number of lines. So this is the current position vertically compared to the total number of lines that we have to check, and I put an unnecessary semicolon right there. So while current down is less than the total distance we need to travel downwards, then the current line equals lines dot get, and this will, instead of remove, and this will be, it'll get current down -1. Then if current line char at current right -1 is equal to a pound, numtrees add 1. Then we're going to do the current right business plus right adjust. Why is right adjust? Oh, I didn't ever define right adjust. Funny. I'm going to define right adjust int right adjust equals right adjustments at index I, and int down adjust equals down adjustments at index of I. So I strategically set up these variables so that each of these pairs would be one of the sets of right and down. So as we iterate through each set, it'll be the correct pair. So here we've got, I just got to refactor this, and I'm going to do it manually because I'm lazy and don't want to right click a bunch of times. Okay, next we have to adjust the current down as well. Down adjust. And we shouldn't have to do this modulus business here because the goal is to get the current down below the size. So once we finish this while loop, we've got our numtrees, and we can say trees product. We're resetting it to equal itself. So for the first iteration, it would be 1 times the numtrees at this slope. Then at the very end, we'll finally print trees product. Alrighty, I'm going to save this and run it. Got a negative number, so clearly that's great. That might be the result of some overflowing, but I'm going to check out. I'm just going to submit it anyways. It's clearly not the right number. Let me do some debugging. The classic. It's going to debug, change perspective. I should already be on this line. So trees product equals 1. Numtrees equals 68. I'm not entirely sure if that's true, but I'm going to run it again and see. At this point, should be here again. Trees product equals 68. The numtree should be 203, or is 203. That should be equal to the original answer that we had, 203. So that works at least. So I'm going to run it again. We got 13,804. Let me pull out my calculator here. 13,804 times 78 equals 1,076,170 or 712. Yes. And numtrees equals 77. Run it. And I've got 82,906,824. And then times 40, I've got a gigantic number. Looks like, I'm not sure why it didn't break there, but this is a gigantic number. it's 3.396273 times 10 to the 9. So let me see if I switch it this way. Oh, if I switch it this way, I get the whole number. So I'm going to try to type this number in from my phone. I feel like I did some overflowing. So it's 3316272,960. Submit. Cool, that's the right answer. So my code works. I just overflow on the integer cap. So maybe I need to, if I want to get the right answer, I need to change from an integer to a larger data type. But for now, I'm going to call that good. So thank you for watching the video. I had a good time. Obviously, this was a very long video, so hopefully I can edit it down so it's not so long. Hopefully there's a lot of parts where I'm just sort of staring at the screen that I can edit out. If not, I hope you like watching code. Otherwise, this pineapple mango orange kickstart, I'm going to actually, this is a 4 stars drink, maybe even 4.5 stars. This is surprisingly good. I like it a lot. All right, merch drops next week.